Hello students, today we will be going over 14.2b, exponential decay. And your objective today, or our objective, is I can write a function that describes exponential situation. We do need some vocabulary. Depreciation, a reduction in the value of an asset with the passage of time due in particular to wear and tear. So we have this first problem that says the population of a town started at 50,400 people and decreased by 3% every year for 5 years. So each year we're going to find out the population after the year. So here we're going to go ahead and enter our population started at 50,400. Okay, so our decrease was that same 50,400 times, what was the decrease? It was 0.03, or basically 3%. And when you figure that out on a calculator, it equals 1512. Okay, so by the end of the year population, we get our handy dandy calculator, 50,400, and we subtract 1512. And again, this is just an estimate, but you should have 48,888. So that's just an estimate. So then that's at the end of year one. So year two, the population is going to be 48,888. And again, it's going to decrease by 0.03. That's how you could write 3%. And we don't get the same number as the one above because we started with less. See how we start with 48,000 instead of 50? So 3% of this is going to equal, I'm going to get my handy dandy calculator out, and I got 1,466.64. Now, because there's no such thing as 0.64 of a person, we're going to go ahead and round that up to 1,467. Okay, so when you're doing story problems, if it doesn't make sense to have a half or have a decimal of something, you need to round to the nearest whole number. So then we take 48,888, we subtract 1,467, and we get our end of year population at the end of year two. So if I do that, handy dandy calculator, so we have 47,421. Okay, now I want you to stop the video, go ahead and put 47,000 in this spot and fill out the rest of the table. When you're finished with that, go ahead and turn the video back on. Okay, so the main idea, exponential decay occurs when a quantity exponentially decreases over time. So our formula for that is going to be A, the amount will equal little a, the amount started with, times 1 minus r is the rate or the percent, and you have to change it to decimal for raised to the power of t, or time, which in generally is annually, but it isn't always annual. So there you have your formula. And if you need just your decay factor, 1 minus r equals your decay factor. Okay, so again, the A is initial amount. That's how many you started with, or how much money you started with. R is the rate. It could be rate of decrease. It could be the interest rate. So I would also put here change percent to decimal. Okay, and then T is time, how much time, and generally it's by year. So it says, what does 1 represent? Like 1 over here and 1 over there. It represents 100%. Okay, so now the population of a town, we get the same problem, but now we can use a formula. What was the initial amount? The initial amount is 50,400, I believe. Okay. And the rate was, it was decreasing by 3%. So there's 3%. And they wanted to know 5 years. Okay. So if we put that into our formula over here, we'll say the total amount will equal 50,400 times 1 minus 0.03. And again, there should be a 0 in front. I'm not sure. Yeah. And then it's raised to the power of 5 for 5 years. Okay. So when you're doing it on the calculator, you need to do this part first for order of operations. So on the calculator, we're going to go 1 minus 0.03 equals, it tells us 0.97. We're going to raise that to the power, y to the x to the power 5 equals, you get a big old long decimal, and then you times that by 50,400. Okay, so I get a decimal, and what I want to do, I need to round it to the nearest whole number, because you can't have 0.1949 of a person. So when I round it, I get 43,280 people. And if we're doing story problems, you have to put your units. I need to know if it's people, feet, yards, whatever. Always, always put your units there. Okay? All right. So I'm trying to think. I think you can do the rest. I think 7 is a little bit difficult. 7 and 8, you're kind of given the end result rather than the beginning result, okay? So we want to start with the formula. Okay? I bought my car 5 years ago. It is now worth $9,000. If it depreciates at 12% per year, what was the initial value of my car? So now we need to know what the initial value was, which is this little a. So the amount here, it says it's now worth $9,000. So I'm going to start with $9,000. And we're going to say that equals, we don't know what little a is, and we get 1 minus, the rate was 12%, 0.12, we change it to a decimal, raised to a power of 5 years ago. Okay. So I'm going to go ahead and do all of this part here. So my next step would be 9,000 equals A, and I'm going to put times, and I'm going to get my handy dandy calculator, and I'm going to say 1 minus 0.12, that's 0.88, y to the x 5, and that's a big old long decimal. So I get 0.5277 31917. You could probably round it to probably 4 decimal places there. Okay. Then I take 9,000. My next step is to take 9,000 and I'm going to divide by the number right here. Because since this is a times all of this, if I divide by that and divide by 9,000, it'll give me my little a, which is what they want, the initial value. So I'm going to put divided by 0.52773 equals a. So the initial amount, 9,000 divided by 0.52773, and I get $17,054.17. So I would get $17,054. And I'm not going to worry about the cents right now. Okay, I think you can finish the rest. That was hard because you're not looking for the big A or the amount. You're looking for the little a. This one right here, you're also looking for the little a. but because there's so many problems, I'm going to have you do all of them on this and maybe have another worksheet for you. I'll have to see. Okay, students, you can get this. You rock.